Okay, thank you, Christian, and welcome everybody. What I would like to share with you over the next few minutes is a technique that I've been using and refining over the last 20 years on and off. And so I thought I might just start at the beginning with the model that prompted me to try this technique out. So here is a model, and I don't expect you to be able to read it on the screen, although if you have the PDF, you can always blow it up. This is an actual model that I produced 20 years ago, a little bit more actually, 22 years, I think now. And it's for a water authority, and it's to support their monitoring of water quality. And this model was produced not using a design tool, and this is significant. All we had was a diagramming tool. I think it was Visio. So there was no database design tool, no data modeling tool. We used Visio for the diagram, and to provide some sort of sustainable process, we were recording the metadata in a spreadsheet. That actually proved to be a godsend, because when we started to walk through this model with business stakeholders, it became clear that it was there was too much information in this diagram for them to grasp precisely what we were proposing. And of course, this diagram didn't tell the whole story. And I thought, no, we have to do this another way. And I will share with you what we did. But let's just talk about the problems of a diagrammatic model. Now, this one is perhaps a bit more dense than your average model, because it does, in fact, show all the attributes. But let's just look at some of the problems that we have with a diagrammatic model. So the whole point of a model is that business stakeholders will review it. It's not simply a case of let's build a model and pass it over to the database designer and let them go for it. We have to get business stakeholder input. But when they come to review a diagram, it's not that easy, because we've got all sorts of different representations. We've got boxes, lines, symbols on the lines, such as crow's feet and so on. And then we have some text. It's also two-dimensional. And this is actually an issue, because I noticed very often that certain reviewers would have completely missed something, because they'd sort of started in the top left-hand corner and wandered around the diagram and bypassed a key entity in many cases. That's the problem in itself, because we want them to review the entire model. And then, of course, there's other information elsewhere. We can possibly show that an attribute is mandatory and that relationships have cardinality and so on, but other business rules that or constraints on the data are very hard to represent on the diagram. And a parallel, if you like, is a transit map of a city. This is part of the Sydney transit system. Now, this model, it is a model, in fact. This diagram, I should call it that, this diagram shows us some information. So if we are near a station, say Lidcombe in the bottom left-hand corner, and we want to go to Chatswood, we can work out that we can take either the if we take the yellow line, that will get us there in one go. But if we take the blue line, then we're going to have to change trains somewhere. But it provides us with some information, but it doesn't tell us, for example, which stations are wheelchair friendly. It doesn't tell us, how to get to specific places. It only tells us how to get to stations. So it's a partial model of the real world. And we live with that. Every major city has a transit map such as this. So that's the parallel that I like to think of when we're talking about diagrams, because I often have people tell me that all you need is a diagram and then everything else falls out, but it doesn't. So big question is, how does a reviewer keep track? And that was my major consideration 20 years ago, as we want the reviewers to review the entire model. So how do we do that? And the solution we came up with was a series of natural language statements. I use that term advisedly because in our case it's English, but this would work perfectly well in any other Indo-European language, be it German, French, And I've actually been working recently with people from the Hungarian and Turkish, Finnish and Estonian language communities, which of course that's a non-Indo-European language. And it seems that a parallel thing could be done there too. So natural language statements, in other words, human language statements that between them completely define, and that's important, a complete definition of either the real world subset that we're modeling, the data that represents that real world subset, the rules that govern that data and the processes that operate on that data. But these statements must also be unambiguous, so they must be carefully worded because, as we know, natural language can be highly ambiguous if we don't take care with how we write the statements. They need to be atomic. By that I mean that rather than combining two facts in the one statement, one of which may be true or required and the other may not be, we separate them out. And I'll give you an example of that just down the track as to what I mean by atomic. They also need to be, this is important, I hadn't realized it at the time, but of course what we realized after we'd started producing these is that they can be searched. So if we have a textual document of some kind that contains all the statements defining a system, then someone can do a search for the word analyte, which is one of the entity names, to see where does analyte get referred to in other entities and so on and so forth. That was a sort of an unexpected byproduct. And finally, what we realized we had available to us was the ability to get reviewers to assess each statement that we made as true, false, or not understood. And so a reviewer would look at the statements and say, well, yeah, that's true, that's true, that's true. No, I don't know, that's false. That's wrong what you've said there. Which means then we obviously need to change something. And the purpose of a review is to get the model right. And then invariably that means some changes. So we can identify which things need to be changed. But of course, there is the third option that, okay, the reviewer doesn't understand what we're saying here. This requires us to have a discussion with them as to establish, have we worded it badly, or is it something that they weren't aware of, or whatever. So this gave us a powerful tool to ensure that the model we had produced met their requirements. Okay, so let's look at some specific statement types. Okay, so there are definition statements, and these are important because in a model we are using entity names and attribute names that we believe are appropriate to the business's understanding of those terms. So by having a definition for each entity name and for each attribute name, we can clarify with the business, is this in fact what you mean by this term? And if not, then how must we adjust that definition to accurately describe what that term actually means? There are also rule statements, and these, as said here, impose constraints on either data, activities, or parties. We'll see some more examples of those in a later slide. Notice that there's a key verb in each case, is in the case of a definition, must in the case of a rule. There are some alternatives to these, but we'll stick to the basic ones for now. And then requirement statements. One of the things that became clear is that there were certain requirements for accuracy of numeric data, such as, for example, timestamps needed to be to the nearest millisecond. So shall is a catch-all for those things that are not so much structural as non-functional requirements. So let's drill down a little bit further. So an entity class, or just entity if you prefer, definition, and this is a repeat of what's on the previous page. It's either an entity in its own right, or it's a subtype of another entity. So we have here the outbound communication entity, which is defined as there, and an invoice is a particular type of outbound communication. So we can have this two-level definition of the supertype of that entity, and then the specific features of the subtype that distinguish it from the other subtypes. Then we need a similar sort of statement for each attribute. These differ simply in that we have not just the attribute, but the name of the containing entity. Now, I had some discussions with colleagues as to whether that was necessary, and there, of course, is a modeling technique which gives every attribute has a unique name. So it does not, the one attribute does not appear in multiple entities. There's another approach that says if an attribute of a given name does appear in multiple entities, it must have exactly the same definition in each of those, but that's not always the case if we look at how business use the terminology. So the default position that I've adopted is to assume that we need to define each attribute in terms of the entity to which it belongs. Now, I'll bring up that issue of atomic definitions or atomic statements that I referred to earlier. One might be tempted to say, to include in this attribute definition that the customer number is unique. Well, that is, in fact, we do need a statement to that effect, but it should not be included in this. One statement is that the customer number is something or other, as we've said here. Another statement applies, gives us the rule that customer numbers are unique. They're two different things because, in fact, the reviewers may agree that the customer number has this definition, but they may not agree that it is unique. Now, that's unlikely in this case, but we felt to maintain the purity of the approach that we would separate out the definitions from any rules applying to those attributes. So let's look at some rule statement types. And data rule statements generally constrain attributes. There can be some other types of data rule statements, but the vast majority of them constrain attributes. And so they typically have the name of the attribute and again the name of the owning entity. And in this case, we're stating that this, sorry, okay, let me step back for a moment. This being what I would refer to as a cardinality rule as to whether an entity has a particular attribute or must have a value for an attribute, then we define it in terms of the entity. The entity must have this attribute or must have a value for an attribute, but where we have and of course here is where the cardinality, or if you like, the mandatory nature of the attribute depends on one of the features of that entity. So a flight booking request for a return journey must specify a return date, whereas a flight booking request for a one-way journey must not specify a return date. And so these statements, of course, allow us to produce a much richer rule model in terms of what is mandatory and what is mandatory, optional, or prohibited. So this is actually a richer form than what we tend to see normally, just mandatory or optional. Activity rules, they constrain the operation of processes or activities, and we have broadened it to consider not only actual processes that occur inside a system, but the human activities that where there are interactions with the system. So one of the rules in a lot of airlines is that online check-in must not occur earlier than 24 hours before the departure time. And of course, that rule may or may not be true. In fact, I've discovered an airline that allows you to check in 48 hours before. So obviously that statement would then need to be modified. And then there are party rule statements, and these restrict the parties who can perform a process or activity or play a role. And typically it's that a person can only do something in certain circumstances, or they must not do something if certain circumstances apply. So a person must not travel alone if they're less than 2 years old. If they're 2 years or greater, then actually, I was surprised that 2 years is the limit. I would have thought it was higher than that, but apparently they can, in some airlines do allow young people to travel. But of course, there are other rules that apply, that there must be someone to pick them up when they get there, and there must be an airline employee who escorts them onto the plane. So, mandatory and optional attributes. So typically, you will find that most modelers, there's basically the choice of mandatory or optional. One of the things that I've discovered in modeling many systems over the past few years is that you can have things that are mandatory in data. In other words, not only are they mandatory in the real world, but they have to be present in the data. Okay, an employee has a family name, and that must be recorded against that employee. But it could be mandatory in the real world, but optional in the data. So each employee has a birth date, which may be omitted from the record of that employee. And then, of course, optional in the real world. An employee may or may not have a middle initial. And I only realized this, of course, when we had produced some statements. And one of the statements we had produced said that a student, this was an education department system, a student may or may not have a father. Well, of course, everybody has a father, but of course, what we were really saying, we were saying that the father is not there's not a mandatory requirement to record the father. And so the fact that the data may be a subset of what's happening in the real world is why we now have this three-way logic rather than two-way logic. So that's the current state of mandatory and optional rule statements. So it's important not to use the phrase may not on its own, because may not can mean must not, or it may mean does not have to. So that ambiguity, the different modalities of that phrase, I'm not quite sure whether German has a similar issue with its modal verbs, but certainly in English that there is that ambiguity. So we never use may not on its own. Okay, there are more complex cases. So what we also discovered is that things are not always mandatory or optional on their own. It depends what other things are there as well. So to be able to contact someone who has booked a flight, they must specify either a mobile phone or an email address or both. However, when it comes to paying for the flight booking, then they must specify one or the other, but not both. So the credit card number or the electronic funds transfer receipt, but not both. And of course, that is one of two, but when it's one of three or more, then we need a slightly different formulation at least there. It must be one of postal address, email address, or fax number. So this allows us to make sure that the data is complete without necessarily limiting it to just mandatory attributes and optional attributes. And then, of course, we can have things that are mandatory depending on circumstances. So, of course, if we have a road vehicle and this road vehicle is a trailer, it won't have a propulsion type, whereas any other road vehicle will have a propulsion type. So this is, if you like, a conditional prohibition of an attribute. Okay, there's various other rules. We can have evaluations, enumerations, sorry, my mistake, enumerations. So travel class must be one of those four. We can have ranges of values. There's a historical matter here that the system, which is still being used for international flight bookings, only ever used one digit for the number of passengers, and that's sort of, they're stuck with it. It's a bit like the year 2000 problem, that they decided 9 was a suitable maximum, and that's not going to change for any time yet. And then, of course, we can have a constraint that applies between two values. Return date and departure date obviously have to be in a particular sequence. The departure date must be before or on the same day as the return date. So those are 3 types there of attribute value rules. And then, of course, whether or not an attribute can be updated. So a customer number must not be updated, or something may be updated in certain circumstances depending on its existing value. So you often get this sort of valid transition between value sets. Okay. Relationships also have rules, and these, of course, are very often, if you're modeling, these will be the rules that jump out at you from the relationships, you know, cardinality and optionality. So that the may and must forms of the relationship name. This is bog standard. And in fact, this is actually where we really started with this verbalization of the model, is in the relationship cardinality. But we decided that we could extend that to cover all the other types of rules as well. Recursion rules.
4 minutes left.
Say again?
4 minutes left.
Fine, okay. Recursion rules are rules relating to recursive relationships. Can you report to or manage can you report to the person who reports to you, or can you report to yourself, and so on? And then, of course, the related to recursion rules is this idea that the departure and arrival ports must be different. So that's actually related to recursion, but isn't obvious. Subtype rules. Can a party belong to more than one subtype? Typically, no, although there are certain relaxations of that rule. But certainly, roles, you can have more. An individual can belong to more than one role. Then temporal and spatial temporal rules. That's basically, you can't be in more than one place at the same time, or time-dependent data must not overlap. So there's some more examples of rules there. And of course, uniqueness, we mustn't forget uniqueness. And so there are various rules to cover uniqueness. Okay, these can all be documented in the design tool. Of course, you need to make sure that your design tool does support some sort of documentation with markers or cardinality, but other constraints you may well need to enter in a textual fashion rather than using any sort of symbols. And the key thing is that you can generate if you have this, then you can generate statements using templates. So here's a couple of templates, and we can just substitute in the entity names. And here's one that's a little bit more complex. So this is an attribute rule. Notice that we firstly substitute in the entity and attribute names, and then, of course, we need to take these optional these options, and of course it'll be a running number rather than an running number, and must be recorded rather than the may be omitted. Okay, so that's where we are at the moment. There is some work in progress. I've been looking at the ways of describing processes completely, and that's still a work in progress. So at this stage, I'm not in a position to report on what's happening there. And another area is in interfaces. So of course, with a wireframe, you've got all sorts of interesting and rich information on a wireframe. So can we describe that wireframe totally in textual form? Not so much the wireframe itself as the features of the individual items on the wireframe, such as the responses to certain inputs and where the outputs come from. Okay then, so that wraps it up for me. There's a couple of books I've written that you may find useful.